All right, let's take a look at FEP Hydraulics, Chapter 4 Homework, Problem 9. We're going to look at the velocity limited procedure. We've got a maximum allowable velocity of 3 feet per second. We also have a drainage area of 6 square miles. That didn't make its way into the problem, but that is going to be important to us because we have an average daily flow for the area of 2.5 cubic feet per second per mile squared. So we'll have to multiply those together to get our Q. We've got 2-to-1 side slopes, and we're designing a low flow channel for the relocated stream of bare earth with weeded sides on a 1.75% grade. And we're going to use that velocity limited procedure to select the channel's base width and depth of flow. So the first thing is, let's go ahead and find that Q. Flow rate, so we'll take that ADF, which is the 2.5 cubic feet per second per mile squared, and multiply it by that drainage area, which is 6 miles squared. So we go ahead and multiply those straight across, and we get 15 cubic feet per second for that Q. We know the maximum velocity that's given to us as 3 feet per second. So the first thing we're going to go ahead and do is find that area of interest, and so here are our formulas we'll be using for velocity limited procedure. We'll find the area just taking the Q over that allowable velocity. We'll find these two terms W1 based on the geometry of the channel and W2 based on the geometry of the channel and the Manning equation. And then from those two we can put them together into this quadratic equation to find our depth Y and then our base B. So let's go ahead and plug that in. So first things first is we'll find that area, just take the Q over the allowable velocity, and in this case, as we just solved for, 15 CFS over that 3 feet per second, and we do get 5 square feet for the area. And now let's go ahead and find that W1 factor. So W1 is defined as M minus 2 times the square root of 1 plus M squared. Look back up to our original problem, and it is 2-to-1 side slope, so our M value is going to be 2. So this just becomes 2 minus 2 times the square root of 2 squared is 4 plus 1 is 5. And so that W1 is going to have a negative value, negative 2.47. And then we'll go ahead and solve for W2, a little bit more complicated there. For W2, we take that area and divide it by the allowable velocity times the Manning's n divided by the conversion factor, 1.486, square root of slope, all raised to the 3/2 power. Now we weren't given a Manning's n for this equation, but we were told it's bare earth with weeded sides. So we can look back in the textbook to that table 4.1, and I'm going to use that earth channel, weeded sides, Manning n 0.05. So put that up here and equals 0.05, but everything else we've got, so let's just plug it in. 5 at the top here. We don't have to put units in because we're going to use a conversion factor there. 3 for my VA, 0.05 for my N, 1.486, and then the square root of that slope, it's a 1.75% grade, so we'll put that in decimal form, 0.0175. And we raise that whole denominator to the 3/2, and I do get 7.5 for that W2. So now it's a question of putting it into the quadratic equation to solve for the depth, and the formula that will follow here is y equals minus, and we'll take the W2 first, plus the square root of W2 squared plus 4W1 times that area, all divided by 2W1. So let's plug the numbers in here. W2 is the 7.5, that'll be a minus 7.5, and then we add on to it 7.5 again squared, plus 4 times the W1, remember that's a negative 2.47, and then that area is the 5. And then that's all divided by 2 times the negative 2.47. And go ahead and solve that equation, and we do wind up with a y value of 0.988, so very close to 1 foot. We'll go ahead and round that up to 1 foot for what we're doing. And then from that y value, we can find the channel width by using the formula for channel width here. It's the area divided by y minus that side slope times y. So in this case, we've got 5 square feet divided by the 1 foot minus 2 times 1 foot. So that's just 5 feet minus 2 feet. And so we do get a final bottom width of 3 feet.